So this would be my third video for this 2.4 to 2.6 review. And at the tail end of the last video, I walked you through how to get this function defined in terms of x, the area of this green rectangle that's inscribed in a circle of radius 17 feet. So we figured that out in the last video. And now what I want to do here is actually try to give you a little bit of an intuitive sense of what's going on. So maybe I can keep that in the frame. So what I want, like I said, I want to give you an intuitive sense of what's happening. If we chose the x to be 1, then we would have an area that would be equal to 4 times 1 times the square root of 289 minus 1 squared, so 288. So whatever that is, so let's go ahead and use the calculator for that part. And so we have 4 times the square root of 288, and that's equal to 67.88. So let's leave it like that. So if we chose our x to be equal to 1, then our, let's say feet, feet squared. So if the x was 1, then the area would be about 68 square feet. Well, what if the area is 2? Well, if the area is 2, we would replace x with 2, and we would get 4 times 2, or 8, times the square root of 289 minus 2 squared. So 289 minus 4, which would be 285. So I'm not going to do this too much longer here, but I do want to give you an intuitive sense of what is going on. The area depends on whatever x we choose. So again, we're trying to figure out what is 8 times the square root of 285, and that is 135.06 square feet. I'm going to come back to that, but for the time being, what we want to do is we want to define our y1. So it's much easier for me to show you how to do these problems on the calculator instead of using Desmos. But if you use Desmos, just open up Desmos and type in into the first box y equals 4x times the square root of 289 minus x squared. All right, so we have this function, and let's look at our numbers here so we can adjust our window. Our x, so if you're on a calculator, you can adjust the lowest x would be a 0, and the highest x, it can't be bigger than 17, so let's leave 17 as another boundary. And then the y min, the area can't be less than 0, and we can see the numbers climbing, so 135. So let's say our y max, we set that at 500. I don't know. That's just a guess. Oh, so it actually goes higher than 500, so let's set that to 700. And if we graph our function, we see here, this is our area function, and here's something that I think you're going to like. So let me zoom out a little bit. This should help you really get a better feel for what is going on. Remember, we calculated by hand the area when x was equal to 1. Well, if we calculate the value of this function when x is equal to 1, we get that same number, 67.88. Let me zoom in on that. We get the same number we got when we did it by hand. But we now see on the graphing calculator, I know it's really probably pretty hard to see, but on the calculator we see when x is 1, y, which again represents the area of that rectangle, dependent upon x. So we calculate the value when x is 1, and we get 67.88. And then if we calculate the value when x is 2, second calculate value, when x is 2, we would get 135.06. And we can see as we move up the graph that as we choose a bigger and bigger value for x, we get a larger and larger area. Now, there is that maximum value that the area can possibly be. So we can see as we look at the numbers, if you're looking at the cursor that's getting towards the top, we can see the maximum value for the area is right around 577, 578. Now we're back down. So it's somewhere right around 578. So if we choose a larger value for x, there does come a point we get diminishing returns. So if you choose the x to be too big, you get an area that's not as big as that 578 that we were looking at. In fact, if you choose x to be bigger than 17, then we don't have any area at all. But so what we want to do is we just want to calculate. Second, calculate. On the calculator, it's just maximum. If you're in Desmos, just put your cursor to the high point and click on it, and it'll lock in the coordinates. But on a calculator, we do second calculate maximum, move the cursor to the left because it's asking us to designate a left bound, enter, and then we move the cursor to the right, enter, and then we back it up a little bit and we hit enter, and we can see our maximum x, or our x that would yield the maximum area, is 12.02. And we can see that the area, the maximum area, would be 578. So let's zoom out a little bit. And the only work that you really have to show for this would be a graph, because you kind of have the graph going out like that. And you would show the ordered pair, what did I say, 12.02, comma 578. So what x value maximizes the area? 12.02 feet. That's the answer to that part. And what is the maximum area? Oh, I guess I didn't notice this. So the x would be 12.02 feet. And the max area, I guess we can just write max area here. Max area is 578, be careful here, square feet. And that's how you do that kind of a problem.